good day everyone. My name is JNB Bayarcal and I am a Bachelor of Secondary Education major in Science student and a first year under the section Block 1B. And for today we are going to solve one of the problems that are given. And so we have here the first problem, which goes like this. Find the density of a 5 kilogram solid cylinder that is 10 centimeters tall and has a radius of 3 centimeters. So, first, we need to understand the problem by identifying the givens. So, we write here the given. First, we have 5 kilograms of solid cylinder, and that stands for the mass of the solid cylinder, which is in symbol of small letter m. So 5 kilograms. And then we have here 10 centimeters tall, and that stands for the height, which is in small letter h, 10 centimeters of solid cylinder. And next we have here the radius, which in symbol of small letter r, 3 centimeters. Notice that in our given we have the unit of centimeters, therefore we need to convert 5 kilograms into grams, and every 1 kilogram is equals to 1,000 grams. So we need to multiply 5 kilograms multiplied by 1,000 grams. We have 5,000 grams. So now let's proceed. What is required in the problem? And that is the density, which is in symbol of rho, density of the solid cylinder. And now let's proceed to this solution. And first we need to write the general formula of density, which is equals to mass over volume. And remember that the volume, the symbol for the volume is always capital letter V. Now, let's substitute the values of the variables. So copy rho is equals to mass, and our mass is equals to 5,000 grams. And since we don't have a fixed value for our volume, so we need to find first the volume of the solid cylinder, of course, which is equals to pi is equals to radius squared and height. And now let us substitute the values for this. Since the value for the pi is constant, which is 3.14, so we don't have any problem for that. And now for the radius, which is equals to 3 centimeters powered by 2, and then we have here our height, which is equals to 10 centimeters. So next is simplify. But let's just copy the 5,000 grams, since we will just focus first on the value for our volume. So copy. In simplifying operations, we need to follow the PEMDAS rules, which goes first to simplify, which is inside the parentheses, and then the multiplication and division and addition and subtraction. But we have only here the operation, which is the multiplication, so we'll just stop in the multiplication. So we'll just copy 3.14 and then simplify, which is inside the parentheses. So 3 to the power of 2, 3 by itself is equals to 9 centimeters. Since it is powered by 2, it will become 9 centimeters squared. 9 centimeters squared. And multiplied by 10 centimeters, therefore we have 90 centimeters. Since we already have 2 exponent here and an imaginary 1 exponent above the 10 centimeters, therefore we have 3 as the exponent. Well, so we have 90 cubic centimeters. Now let's simplify in order to finally get the value of our volume. So the mass and then the volume is equals to 3.14 multiplied by 90 is equals to 282.6. 282.6 remain or copy our unit, which is equals to cubic centimeters. So now we can now find the value of our density because we already have our values. So simplify. 5,000 grams divided by 282.6, which is equals to 17.69285,209. And since in our given, we can see that it already it we can see that it just need three significant figures. Therefore, we will just stop at the three significant figure. So 1, 2, 3. Therefore, we'll just stop at this number 6 and look what is after. What is the value after number 6? If it is above 5 or below 5, and if it is above 5, therefore we need to round it up. So as we can see that it is above 5, we will round it up, and so it will become 17.7. So our final answer would be 17.7 copy grams per cubic centimeters. So that is our final answer, the density of the solid cylinder. So that would be all, and thank you.